Hello, everyone, and welcome to another episode of Mechanical Drawing 202. Now, this episode will be a continuation of the last episode. In the last episode, we were looking at spur gears and some of the important parameters that we need to know in order to construct a spur gear. We were also looking at the different parts of a spur gear. And here are the images that we were looking at. And if you want to study this some more, you can ref revert to the previous video that was created on this. All right. So if you look at this image here, you will realize that there are four circles here. 1, 2, 3, and 4. The root circle, the base circle, the pitch circle, and the addendum circle. All four circles are critical in constructing the gear tooth profile or the spur gear itself. Now, I've seen where various persons start off with various circles, but I like to start off with the pitch circle. I realize that most persons start off with the pitch circle, right? And for a very good reason. To me, it's easier that way. So today we are going to construct a spur gear. Let me show you this two spur gears meshing. Let me show you the picture, the image of the spur gear that we're going to, the spur gears that we're going to draw today. These two involute spur gears. As we can see, they are of different sizes, but they have a relationship, and that relationship will be important. Now, depending on the circumstances, the relationship may vary. You may have two spur gears that are equal in size. You may have two spur gears that have a ratio between them. For example, this spur gear, the ratio between this spur gear is 4 to 5. So this spur gear, the pitch circle diameter is 100. I was working unitless, but let's say 100 millimeters. The pitch circle diameter for this gear, since the ratio is 4 to 5, the pitch circle diameter is 80 millimeters. Now, remember those formulas that I was telling you about in the last video? Well, here they are. Once you have the pitch circle diameter, you will assume a number of teeth, right? All right. If you are given an exercise where you are required to construct a spur gear, they may give you the number of teeth. If not, you have to determine the number of teeth depending on the circumstance. All right. So these formulas are critical. So once you know the pitch circle diameter, which I've already told you that is 100 millimeters, and the number of teeth, we're going to work with 20. Then you can now find what we call the diametral pitch. The diametral pitch is a very important parameter to find. This can allow you to obtain a lot of other parameters. One such parameter is the number of teeth for the second spur gear. So I already told you that the pitch circle diameter for this spur gear is 100. The pitch circle diameter for this spur gear is 80. And I already told you that the number of teeth for the first gear is 20. Now, we need to find out the amount of teeth for the second spur gear. And that's where this formula is important. The reason why we can use that formula to determine the number of teeth on this side is due to the fact that when two gears are meshing, the diametral pitch for the gears are equal. So let's find the diametral pitch for the first gear by using the formula. The diametral pitch would simply be 0.2. Now the number of teeth is 20, and that is divided by the pitch circle diameter or the pitch diameter, and the answer will be 0.2. Once you have this, you immediately know that the pitch diameter required for the second gear would also be 0.2. Now, if you use a formula like this, right here, you will be able to determine the number of teeth for the second spur gear. And let me show you how this would work. This is the equation, and then you will just insert the values. This T1 stands for the number of teeth for the first gear. T2 stands for the number of teeth for the second gear. This is what we want to find, T2. Pitch circle diameter for the first gear is 100, as I said before. The second one is 80. Now, as we work out the formula, you'll bring across the 80. Now it will be multiplied by whatever is here, and we already know that the pitch circle diameter for the circle is 0.2. That is multiplied by 80, and the answer will be, I should have worked this out further. The answer will be 16. So we have successfully determined the number of teeth that is required for the second gear. And as you can see, that's what I did. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 teeth. All right. So after we have found the number of teeth for the second spur gear, we can now proceed. We could have worked it out after. We didn't have to do it immediately. But this is what we need to do next in order to move from this stage. By the way, this circle that I have here is the pitch circle. This is 100 millimeters in diameter, as you can see here. Right where the mouse is, 100 millimeters in diameter. Now I also need the dedendum circle, the addendum circle, and the base circle. Now, the other formula, which is the module formula, or equation rather, can be used to determine the addendum and the dedendum. So, this is the formula here. So we have to work out the module. So, whereas the diametral pitch is the number of teeth divided by the pitch diameter, the module is the reverse. That is the pitch diameter divided by the number of teeth. Now, 100 divided by 20 is 5. This means that the module is 5 for the spur gear. If we divide 16 by 80, you would also get 5. So the module for the gear design, the whole entire gear design with the two gears meshing together, is 5 in this situation. Now we are going to use the module to determine the addendum and the dedendum. Now, let me search for this here. All right. There are various values that are used for the addendum and the dedendum in relation to the module. For example, the most common value for the addendum is M. The addendum is normally equal to the module, and the dedendum is normally equal to 1.5 modules. So whatever the module is, which is 5, you multiply 1.5 by the module, and you'll get the dedendum. This is not always the case. You have different addendum values. Sometimes it can be greater than 1, meaning greater than 1 module. In this case, this is 1 times the module. And the module is 5, so the answer is 5. In this case, 1.5 times the module, the dedendum is 6.25 based on the equation. Sometimes the dedendum can be 1.35, it can even be larger. The same goes for the addendum. But based on what I have seen, the most common values that are used are 1 for the addendum and 1.25 for the dedendum, meaning 1 module addendum, 1.25 dedendum. In some cases, they might give you, if you encounter this question on an exam paper, for example, they may give you the addendum and the dedendum. If they have not, I'm assuming that they may give you the liberty of finding the addendum and the dedendum on your own. There are other ways to get the addendum and the dedendum separate and apart from how I've calculated it here. Same goes for some of the other values that are seen here, like the number of teeth and so forth. All right. but I'm just showing you the most basic ways, or the most common ways, or the way that I find the easiest. And these values will be determined based on other factors, because when designing a spur gear, there are a lot of other factors to determine, so that the gear can bear the particular load that it needs to bear, so that there's no wear and tear. And I'll try to explain some of them further. All right, so once we have the addendum and the dedendum, we can now um, find the addendum circle and the dedendum circle. All right, now these circles will be concentric circles to the pitch circle. The distance between the addendum circle, in terms of the circumference, the edge, and the pitch circle will be 5. So if the radius of the pitch circle is 50, addendum circle, the radius is 5 more, which would mean that the pitch circle, the addendum circle radius, um, addendum circle diameter, sorry, would be 5, would be addendum times 2 plus the pitch circle diameter. If you were working with the radius, it would be just the addendum times the radius. All right, so this is the addendum circle diameter. The dedendum circle diameter now it would be the dedendum times 2, and this would be minus because the dedendum circle is smaller. All right, so let's work this out. Let me pull this down. AutoCAD has an easy way of doing this, but I just want to show you this way. The addendum is 5 times 2, which is 10, and the pitch circle diameter is 100. So if you're supposed to break this down further, you will realize that this would be 10 times 100, and your answer would be 110. And that is 110 whatever unit you're working with. Let me put that correctly. The dedendum circle is the same. You use this formula here, and this would be, the dedendum in this case is 6.25 times 2 minus the pitch circle diameter. So let's go further down with the equation. So 6.25 times 2 is 12.5, and the pitch circle diameter is 100. So I could have just easily told you the answer, but I wanted you to see the working out. This should have been the other way around, because you'll get a negative number. So this should have been 100 minus the 12.5. Let me do the necessary corrections here. So the answer should be 87.5. All right, so this should be so this is the formula. So the pitch circle, you could have done the same thing for this, but it doesn't matter because it's addition. The pitch circle plus or minus the addendum or the addendum, depending on whichever you're using. Now you can simply select the circle command and draw the addendum circle, and it is asking for the radius down here. You can just type D, enter, and then you type 87.5. That's the addendum circle. The addendum circle using the same center now, 110. Oh, I've typed the radius instead of the diameter. So you press D, enter, then 110. Now, let me show you something very interesting. You could have simply just offset at a distance of 5 the addendum outwards. If you notice, it overlaps the circle because it's the same measurement. And you could have just offset 6.25 inwards. And if you notice, it's overlapping the inside circle. Let me just color code these. So the addendum is the root circle, the addendum circle is the root circle, the outside circle is the addendum circle, interchangeable names. So now you have the addendum and the addendum. Alright, and this is what I'm going to do. Ahead of time, I am going to draw a line that is equal to the radius of both of these circles combined, the pitch circle diameters. So this is 100, this is, well, the radius rather, this is 50, the other radius should be 40, so I would have 90, because 40 is the radius for the pitch circle diameter, 40 is the radius for the other pitch circle. So that is it. So this circle is kissing this circle, the radius of this circle is 40, the radius of this circle is 50, diameter of this circle is 80, diameter of this circle is 100. Now, when two gears are working in unison and are meshing, both pitch circle circles must meet at this point that is referred to as the pitch point. I did not mention this point before. This is the point where the gear tooth from each gear will meet. Both teeth will meet here. They will touch here at the pitch point. They may touch at other points which you don't want, and that is if the backlash is 0. And I'll explain that further down the line. Once the backlash is 0, the gear will be susceptible to wear and tear because the teeth will be grinding against each other in a way that you don't want. The teeth has to touch to give the motion, but you don't want them to be touching on both sides. And you also don't want them to be touching on the each other. Like, for example, let me show you what I'm talking about. You want some clearance. That is the term that is used. You want some clearance. The bottom land here, the teeth are not supposed to touch the bottom land. They are not supposed to touch even the fillet curve. So let's get back to the drawing. Where is it? Okay, this is the drawing. Before we proceed any further, we already know that this gear requires 20 teeth. This gear requires 16 teeth. We need to now find the base circle. Right? The base circle is critical. And the base circle will be used to construct the gear profile or the involute curve that will be used to form the curves of the teeth. So let's go ahead, and this is a line. We have to draw a line tangential to the pitch circle diameter for both circles, because this is the pitch circle diameter. The line is tangential and to both. All right, and you have something that is referred to as the pressure angle, and you have something that is referred to as the pressure line. So I'm going to rotate this line to the pressure angle. Then I'm going to draw another line that will represent the tangent. All right. So this line is 20 degrees to the tangent of the pitch circle diameters. This pressure angle, the various pressure angles are used In the past, it was 14.5 mostly. Nowadays, we are using pressure angles of 20 and 25. Mostly 20. These angles affect how the gears work. They affect a lot of things and the functionality, how smooth the gears work. Now, this pressure angle is critical because this pressure angle is the normal to the base circle diameter. It's the normal to that diameter or the radius of this base circle. So what we need to do now is to copy this line, and we're going to rotate it 90 degrees so that it now becomes perpendicular. So it's now, so this line now, where I'm going to move it from one of the ends, place it at the center. You have to ensure that the center snap is on. Where is it? Right here. So that you can place this line at the center here. And if you notice, it is intersecting the pressure line. It is intersecting the pressure line at this point. This point is where the base circle will be drawn. So from the center, so from this point to this point is the radius of the base circle. So now we have drawn our base circle. I'll just leave that line there for now. I'm going to put it in different colors. And I no longer need this. Before I delete it, additionally, this line and this line is also 20 degrees. Okay, so whatever the pressure angle is, it is also shown here. So let me remove this. I don't need this anymore. I can easily get it back. I'm going to also leave this line. All right. I'm probably able to delete it at the moment. So I'm going to indicate the base circle. My base circle is in this purplish color. All right. Now that we have the base line or the base circle, we can now construct our involute curve. Now I'm going to copy this. Take it out of the way. I'm going to bring it here. And I'm going to divide it in some spaces that are equivalent to the number of teeth. Now there are 20 teeth, so I'm going to divide it in 20. I'm going to use a command that is called array. It is right here. Now you have different types of arrays. You have rectangular array, path array, and polar array. Now since we are operating from the center of the circle, we'll use polar array. All right, so this line, we select the object, press enter, then you select the center point. You have to read the command as you're going along. Then notice by default it is set to 6 divisions. You type items. There are some other options there, but for what you want to type items, enter. Then you type 20. Now there will be 20 divisions of the circle. And I think I should have brought this down to the base circle. So let me do that again. So click the line, enter the center, then the items, then we type 20. So now the base circle is divided into 20 parts. All right. There's something that we need to work out, and that is called the circular pitch. That is a critical thing for us to work out. Working out the circular pitch will help us to construct the involute. So let me circular pitch. All right, let me show you something. If you notice on this drawing that I showed you in the last video, you will realize that you have the tooth thickness and you have the tooth space. Now the tooth thickness plus the tooth space together, that distance adds up to give you the circular pitch. All right. Now let me show you how to get the circular pitch now. The circular pitch is given by pi. How do I get pi here? Pi. I need a symbol for pi. Alright, let me see if I can find one. It should be here somewhere. I really don't want to type pi. Oh, I'm not finding it. Alright, so let me see if it is here. Let me go again. So you're basically finding the circumference of the circle and you're dividing it by the number of teeth. So let me do that. And it is pi. Let me just type pi times base, and it's the base circle diameter. That is critical to note. Let me try again. It is not here. Okay, we have to do without that. Just know that it's pi. Alright, so let's continue. The equation will show that it's pi. Let me move this further up so that it doesn't clash with the diametral pitch equation. So we already know that pi is 3.1428, etc. Let me try to work it out. Pi is normally 22 divided by 7, and we have this long number 57. Let me put the 7 and times the base circle diameter. Now we have to measure the base circle. Let's go back here. It is 40, not, that is the radius. It is 93.9693. I'm going to just put everything because it's not a whole number. I like to be as precise as possible. So 96.9396, and the number of teeth is 20. So let me work that out for you. So 22 divided by 7 is equal, and then we multiply that by 96.9396. So this is the circumference of the base circle, and we divide that by the number of teeth, and we get 15.23. Alright, let me see something here. I may have done it to the wrong circle. Let me just double check. Okay, it's the right circle, so I'm correct. What did I get there? 15.23. Okay, so let me work with that. Let me see something here. 304.67. And then the pitch circle, the circular pitch rather, is 15.23. All right. What do we do with this circular pitch? It will be, as remember when we were drawing an involute, what the amount of size that we divide, the amount of pies that we divide the circle in, um, we have to divide the circumference by that, and that would be the first length. So 15.23. Let me see if that's what I calculated. Yes. All right. Wondering if something is wrong with this. I'm thinking it might be. When I did this initially, I got another measurement. Let me do some calculations again. All right. So the diameter of the circle, just to confirm, that is the diameter of the circle. And let me use, so 22 divided by 7 is pi, and we multiply that by 96.9396, and that answer we divide by 20, and you get 15.23. Okay, I'm just going to work with that. I'm going to work with that. 15.23. I'm just remembering that the line seemed longer because it's straight, while this is a curve. Okay, so that settles it. This line seems longer than this arc, what it actually isn't, because this is a curve rather than a straight line. All right, so I'm going to ensure. All right, so whatever this measurement is, this is perpendicular to this. There must be another line perpendicular to this with twice this measurement, then this one with thrice the measurement, and this one with 4 times the measurement, 5 times the measurement. That's how we construct an involute. But we were accustomed in lower levels to construct the involute with 12 divisions. Now we have to get a bit more creative. I'm going to use the polar array command. Select the object that I want to array, press enter, select the center point of the array, then I type items to select the amount of items that I want in the array, and that will be 20. Then press enter. If you notice, on each line there is another line that is perpendicular. I have to explode these. I have to explode it so that you can select it individually. If you don't explode it, they will be all selected at once. So this is one. I don't need this. I don't need this. Don't need the others because I won't do it all the way around. I just need a portion of the involute. So this now should be twice the measurement. So I'll simply just copy. 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 All right. So this is twice. This should be thrice. So I should do one more. 3 times. This should be 4 times. So I should do one more. You can actually calculate it and just draw the line at the length, but that will be more difficult. On paper, that is the method that you would do, but since you're using AutoCAD, it's 1, 2, 3, 4. I think this is 5. 4 plus the one that was there. Since you're using AutoCAD, this is the easier method. And please be careful where you click on the line. You might accidentally put it here instead of here, and that might throw off it will throw off the involute, even by a little, but it will still throw it off. So I may not need to go this far with it, but I like to be on the safe side. So I'm going to start here, then here. The more points you use for the involute, the more accurate it will be at the start right here. So this is the gear. This is the tooth profile. Let me copy this. I like to copy my progress. Alright, so this is the involute curve for the teeth. I am going to now delete all of this. I have it here if I need it back. I'm going to also remove all of this. Oh, I've deleted the profile by accident. So this is the involute profile for the Spur gear. All right, so once we have this involute profile, the tooth profile, we can now bring it across here, and then we can now go ahead and draw the rest of teeth. All right, so I'll stop here for now. I'll stop here for now because it's a lot to process. So just please observe the formulas once more. Let me recap what I've done so far. The first thing I did was to work out the diametral pitch and the module. And this is the diametral pitch. This is the module. And I've used the diametral pitch to determine the number of teeth for the second gear, because we were given the number of teeth for the first gear and the pitch diameter for the first gear and the pitch diameter for the second gear. So we have to work out the number of teeth for the second gear. After we did that, we now worked out the addendum and the dedendum, and as I was saying, there are a number of ways to work them out, but this is the way that is common, one of the common ways. Now this is the answer for working out the addendum circle diameter and the dedendum circle diameter. You can of course just draw the circles using the measurements that are given here, or you can just offset the pitch circle by the addendum to get the addendum circle, and then offset it by the dedendum to get the dedendum circle, which is 5 and 6.25 respectively. And after which I created a tangent to the pitch circle diameter at the point where we call the pitch point, the point where both pitch circles will meet, right? Then I've created a 20-degree angle to call, so this is the pressure line now at that 20-degree angle. Then what I did here was find a perpendicular line to this line, placed at the center of these circles, and wherever it meets this pressure line, that's where the diameter of this base circle will fall. So once we have the base circle, we now go ahead and construct our gear tooth profile, the involute that will be used for the gear tooth profile. And this is worked out by finding the circular pitch. You need a circular pitch because this is how you get it. Pi times the base circle diameter, that is the circumference of the base circle, divided by the number of teeth, and we'll get the circular pitch. And please remember that the circular pitch is a sum of the tooth thickness and the space between each tooth. The space between two teeth, rather. So that is how you get the pitch circle diameter. And if the space, note this carefully, if the space of the pitch of the, let me show you, once, here is it, okay, here is it, once the tooth space is equal to the tooth thickness, you will have a backlash of 0. What is backlash? Okay, naturally, when you design a gear tooth and the tooth space and the tooth thickness are the same, you have a backlash of 0. What does that mean? Now here is where this is the pitch point where both pitch circles meet here and the gear meets here. But if you notice, the gear is also meeting over here. That's because the backlash is 0. Once the backlash is 0, this gear will tend to jam. There's a possibility of the gears jamming because of the friction that will be caused over this side. So let's say, for example, this gear is rotating in this motion. It will force this gear to rotate in this motion. As a result, this gear will be pressing on this gear at the pitch point. And once the gears are rotating, it will also contact on the other side, and as such, it will create friction, unnecessary friction, which will cause the gear to wear over time. Now, as to how quick it will wear, it depends on a lot of factors. So you would want to naturally design the gear in such a way that the gear tooth is not the same thickness as the space between the teeth. But for this example that I'm doing here, because this is the finished product. This example, I have the backlash at 0, but just for the sake of the demonstration. Okay, so we'll pause for now, and we will continue this in the next lesson, in the next video. So please like, share, and subscribe. If you have questions thus far, please leave them in the comment section, and I will be happy to assist and answer your questions or your concerns. Have a good day.